Welcome to Kiwi Takes Flight. I'm assembling a kit aircraft in my single car garage and designing and building electronic systems for my aircraft. This episode I'll be installing wiring in the elevator, which is to actuate the trim servo and the trim control board that I'm building. This is of course the elevator with the trim tab that gets actuated by the servo that sits in there, and that is connected to my control board. This isn't the final version, but it is functional and I'll be able to use that to demonstrate this thing working. Once I've run the wires, I'll be able to put this front skin on, and that'll close this up and my wires will be inside it, never to be seen again. The wires I need to run is a red and black 18 AWG. It's a mil-spec wire, which is aircraft grade, meaning that it's got Teflon insulation, which has a high temperature rating, as well as the strands are individually tinned. So although it is copper wire, the ends of it look like it would be aluminium or tin or something, but it's not. It's tinned to prevent corrosion. And I also need to run a twisted pair CAN bus, which I have these spools of 22 AWG wire for. The purpose of the twists in a CAN bus is to reduce interference. The signal in a CAN bus electrically is a differential pair, which explained simply means when one wire goes up, the other one goes down. But that means that all common mode interference or interference that affects both wires from anywhere else in the aircraft and the world will affect both wires. But for example, if there's common mode interference that increases the current or the voltage in the wires, it'll increase it in both of them, and one's positive and one's negative. And so the difference between them remains the same. And through that, you get a lot of noise immunity. what I've just shown you is how you're not supposed to put these connectors together. First of all, there's a tool you buy which you use for crimping these little things. I think I bought the expensive ones too because these are gold plated. Anyway, there's a very expensive tool that you use to crimp them correctly. And of course I'm just having a go with my old rusted pair of pliers since my childhood, and one of them pulled out on me. So I went to what I know best and added some solder to it. You're not supposed to add solder to any kind of crimped connection because the solder can wick up the wire and cause it to harden, and then it becomes a fatigue point. But in all practicalness, I could well find myself soldering these connectors. The crimps are so small that I would struggle to trust them. These aren't the plugs that I will be using in the final version of the circuit. I've got a slightly larger 4-way plug that I'll be using, so I'll be combining these two, power and CAN bus, into a 4-way plug. So there'll only be one plug into each board. And the plug is slightly bigger, which will help, but I think a small dab of solder just on the end is probably more security than it takes away in terms of any fatigue. And of course I'll be heat shrinking over the joint and strain relieving and all of that anyway. I didn't think about this until now, but the small zip tie fixtures I will be using to hold the wires, which go around there, tighten the zip tie and fasten this to something, for me, with a rivet. The issue I've got though is I can't pull this rivet. The heads of my riveters are way too big and will not get down there flat. In fact, that's not even going to work at all with the pneumatic riveter. I found a small nylock nut of all things that I can chuck down there to get some more clearance, and then I was going to chuck that on there, but that's still not going to work. That's my pneumatic riveter, but this will work with the hand puller because I was checking that before. That is a big fail. The problem when these snap off where they're not supposed to is you can't drill them out. And I had 3 or 4 of these rivets that did this on my rudder, and I had to take the angle grinder to chop off the steel mandrel, so this sticking out bit, and grind them out. It was successful on the rudder, but it's a nightmare. I've only had it happen with the hand puller. And in this case, I was obviously doing, some things with a nut on there, trying to space it out. But I'm not going to risk that because I cannot have one of these get stuck in my elevator. That would not be cool. To cut this rod to the right length, and it's important that it's the right length for this to sit in the right distance. I just whipped up a 9-volt battery headline round and jumped that onto the trim servo to drive it fully inwards. And now I can set this to the position where the trim is sitting 20 degrees deflected down. Yes, yes, that's down. The easy way of doing this would be if you had a little cube digital level and you could just set that to 20 degrees, easy. But what I've done is measured the distance with the flat down to the hinge, and that comes out at 105 millimeters. And then I've gone over to a trusty right angle triangle calculator and punched in 105 degrees, so that's B, so that's like across there. And then I need 20 degrees, and so that calculates A as 38 millimeters. So I need to raise the trailing edge 38 millimeters, which is sitting just over there. So it'll be slightly more than 20 degrees, probably about 21, 22 degrees, something like that. I have this testing app that I've put together, and we can move it. I've got these buttons for up and down, which will actuate the trim, and that's not at full speed, that's at roughly half power, but of course I can change the speed to be whatever I want, and you'll see that it's got the actual position there as well, so as it moves, this updates with its current position. You can also tell it to move to a certain point and it'll just move straight there. Whether there's an application for that in the aircraft or not, I don't know yet, but something it can do. Thanks for watching. If you found this interesting, you might enjoy some upcoming videos around redesigning that controller circuit. I'll be trying to make them not overly technical and interesting enough, even though it is still circuit design, which can be quite a technical task. But all things to look forward to. I hope you'll join me on the journey.